Welcome to Fenna e-learning. The title of the project is Automatic Speaker Identification System using Gaussian Model. The objective of the project is to identify the person who has spoken using Gaussian model. In the pre-processing step, we have to perform silence removal, speech denoising, framing, windowing, fast Fourier transform, preemphasis operations are performed. Uniform filter bank and non-uniform filter banks are designed to extract the features. Similarity-based measurement is used for classification. So what is speaker identification? The goal of speaker identification is to determine which one of the known voice in our database is best matched to the input voice sample. There are two types of speaker identification system. First one is text dependent, another one is text independent. In text dependent system, we have to identify the set of words used for verification. For example, if we set the password for our laptop is Dell, then the same Dell word has to be recognized by the system. But in text independent system, we have to verify the voice of the person without the constraints of the speech content. This is the methodology used in the project. We have two steps. The first step is training phase, another one is testing phase. In the training phase, we have to maintain the speech database, and from the stored speech signal, we have to pre-process the signal, and then features are extracted, and then Gaussian mixture models are used, and the parameter database is maintained in the training phase. In the testing phase, we have to give a signal from our trained database, or we have to give a random speech signal that has to be pre-processed and feature extracted, and Gaussian mixture model operation is performed, and the parameters are extracted and matched with the trained database, and based on the similarity we have to identify the speaker. And this is the sample input speech signal from the database. This is the silence removal operations. In silence removal operations, the samples with near zero values are removed. So this is to reduce the complexity of the signal present in the database. So this is the signal before silence removal. This is the signal after silence removal. Wavelet based denoising operation is performed to remove the noise present in the signal. So here three steps operation we have to perform for denoising the speech signal. In the first step, we have to perform wavelet decomposition. In the second step, denoising operation is performed using soft thresholding. And the third step, reconstruction of the speech signal is performed by using inverse wavelet transform. This is the output of denoising speech signal. Framing is the process of segmenting the speech samples into small frames to reduce the loss present in the signal. And the number of samples in a frame is equal to 256, and number of overlap is equal to 156, and this is the framing output of the speech signal. The windowing operation is performed by using Hamming window. The advantages of Hamming windows are the main lobe is wider and lower side lobes, and this is the windowing operation output of the speech signal. And fast Fourier transform is used to obtain the spectrum of the speech signal, and this diagram explains the spectrum of the speech waveform. Preembosis operation is a signal processing technique which increases the amplitude of high frequency bands and decreases the amplitude of lower bands, and this is used to perform spectral flattening of the speech signal. And this operation is performed by using the formula y of I equal to x of I minus x of I minus 1 into preemphasis factor. X of I indicates the present sample and x of I minus 1 indicates the past sample, and the preemphasis factor used is 0.97. This is the preemphasis output of the speech signal. And the filter bank implementations are performed by using uniform filter bank and non-uniform filter bank. In uniform filter bank, the channel bandwidth is uniform, and in non-uniform filter bank, the channel bandwidth is not uniform. The center frequency of uniform filter bank is f of I equal to f of s divided by n into I, where f of s equal to sampling rate, n equal to number of uniformly spaced filters, and q equal to the number of filters used in the filter bank. The bandwidth of the ith filter satisfies the condition q less than or equal to n divided by 2. The center frequency of is given by f of I is equal to f of s divided by n into I. This is the structure of uniform filter bank, and this is the structure of designed non-uniform filter bank, and this is the structure of MEL filter bank structures. And the Gaussian mixture model is based on probabilistic theory that consider all the data points are generated from a mixture of a finite number of Gaussian distributions with unknown parameter, and this is best suited for text independent and individual component Gaussian represents some broad acoustic classes. The Gaussian mixture model is based on Gaussian mixture density parameter, which is given by P of x bar divided by lambda equal to summation I equal to 1 to m P of I bi into x bar. Parameters of the Gaussian mixture model equal to lambda equal to pi comma mu I into summation of I. Pi represents the mixture weights and mu I represents mean vector and sigma I represents covariance matrix. And these all parameters are derived by using these formulas: mean, variance and posterior probability. And this is the results. So for two kinds of results are analyzed. The first case 1 second speech utterance is used, and the second case 2 second speech utterance is used. If we used 1 second speech utterances with 4, 8, 16, 32 Gaussian mixture model, the accuracy obtained is 80% maximum for 8 Gaussian number of mixture components. And if we increase the number of speakers, that results also reduced. If we used 20 second speech utterances, we get better results for 20 number of speakers with Gaussian number of mixture components as 8, 16, 32, and the accuracy obtained is greater than 90%. This is the identification performance of 20 second speech utterances applications. These projects can be used in banking over telephone, computer security using voice, access secure documents over internet using speech. And these are the references related to this project. Thank you. Thank you for watching this video. Kindly subscribe, support the work. Thank you.